We are looking at lesson 2.2 notes, and our topic today is direct variation. So before we go into slope-intercept form and slope and all that stuff that we'll move into in lesson 2.3, we're going to review direct variation. So direct variation function is written as y equals kx. That's going to be an important form to remember there. So anytime you're asked to write a direct variation function, y equals kx is a popular one to use, getting that y equals. We also sometimes use the form k equals yx. So if we're trying to find our k value, we sometimes use that. K standing for the constant of variation. So k is that relationship between x and y, constant of variation. And then an important phrase that you'll see is y varies directly with x. That's the phrase that will help us set this up. So y varies makes me think y equals. Varies directly means we're multiplying by some constant, which we call k. Now we're going to do several different things with these today. First one, given a chart of values, is this direct variation? So for each function, determine whether y varies directly with x. If so, what is the constant variation and the function rule? Okay, or in other words, what is the equation? So if this is direct variation, it has to fit these equations up here, doesn't it? Mm-hmm. Okay, and my recommendation is that you use that equation, k equals y over x, to decide. If we use that equation, k equals y over x, if it's direct variation, all of those values will work. If it's not direct variation, you'll end up with different values. But if they're all the same values, that means it's direct variation. So if we look at these, my first ordered pair is 1, 2. So if I'm checking to see what k is, y divided by x, well, we'd be doing 2 divided by 1. And what is 2 divided by 1? 2. Check the next pair. What am I dividing here? And 6 divided by 3 is 2. Check the next pair. 8 divided by 4 is 2. Okay, guys, this all worked out the same. What do you think? Is this an example of direct variation? Yes. Okay. So my answer is yes. Now, if so, what is the constant of variation? K is 2. Because in order to find k, we do y divided by x. And we got 2 every time. So k is 2. And then the other thing, what is the constant variation? And then what is it says function rule, but notice in parentheses it says equation. So when I'm looking for the equation, if my equation is y equals kx, what can I fill in there? What is k?
2.
2. So I can write my equation as y equals 2x. So that is all the information you would need, yikes, to answer that question. Try B. Again, I want to know if it's direct variation, so we're going to check y divided by x. What's the first set? And 4 divided by 1 is 4. Okay, check the next set. 8 divided by 2 is 4. So far, so good. Should I quit?
No.
No, it has to work for all of them. Last set, 11 divided by 3. Okay, the calculator says 3.6 repeating. Even if I don't have the calculator in front of me, here's what I know. 11 divided by 3 is not 4.
All divided by 3 is.
Okay, and that's the thing. I know 12 divided by 3 is 4, so I know 11 divided by 3 is 9. So what do we know?
It's not.
Yeah, this is not direct variation. And why?
Because 11 divided by 3 is not 4.
Yeah, I got two different values there. I got a 4, I got a 3.6. As soon as you get two different values, you can quit. Look at the next one. Are you starting to divide them? What are you dividing? It's y divided by x. So what is negative 21 divided by 3? Negative 7. Next one. Negative 14 divided by 2?
Negative 7.
Negative 7. Last one.
Negative 7 divided by 1, negative 7.
Negative 7 divided by 1. Negative 7. What about this one? Is it direct variation? Yeah, it is direct variation, isn't it? Because this time all my y's divided by x to be the same number. So I'm going to say yes. What is the constant of variation?
K equals negative 7.
Okay, because they all divided to be negative 7. K is negative 7. What is my equation? Okay, good. Y equals negative 7 times x. Because up here it says y equals kx, we're going to say y equals negative 7 times x. Okay? Getting the hang of it? Check D out. In order to find if it's direct variation, does y divide by x to be the same number? Y divided by x. 5 divided by 2 is 2.5. 7 divided by 3 is 2.3 repeating. Do I need to keep going?
No.
No, I don't need to keep going, do I? They're not the same. So right there, because they are not the same, they are not equal, we can say, no, this is not direct variation. Okay? Not horrible, is it? No. Want to have the equation in front of you, right? This is why you have your notes. Okay, example set 2. This time, they're giving us an equation instead of x, y values. They want to know, is this direct variation? Does y vary directly with x? What's that basic form of the equation from up top?
X equals y.
Yeah. Y equals kx is what I'm looking for there. Okay, so if we can make these the form y equals kx, where k is some number, then it's direct variation. If we can't get it to be y equals some number, like some number times x, it's not direct variation. Okay? So, my question to you, how are you going to solve this equation for y? Okay. If it's 3 times y, you guys are expert equation solvers, right? In order to get y by itself, since it's times 3, we're going to divide by 3. If we divide the left by 3, we divide the right by 3. So then, my 3's cancel. Y equals, okay, we took 7x and we divided by 3. How can I write that? 7 over 3 times x. Does that fit direct variation? It It does, doesn't it? Because, I mean, here's the deal. Is it y equals some number times x? Yes. Y equals some number times x. So the answer is yes. And with that in mind, okay, it's always asking, what is the constant of variation? So what is k? In the k spot is 7/3. So k is 7/3. Okay? Okay. B. 7y equals 14x plus 7. The question is, how do I make it y equals? So to get y by itself, divide by 7. If I divide the left by 7, divide the right by 7. Divide everybody by 7. 7y divided by 7? Just y. 14x divided by 7? 2x. Plus 7 divided by 7? 1. Does this fit the form y equals a number times x? No, this is y equals a number times x plus a number. Is plus a number part of the form? No. It needs to be y equals a number times x. So this is not direct variation, all because of that plus 1. Okay? Make sure you're in the notes with me, please. Following along in the notes, not on the iPads. Put them up right now. Okay. C. What am I going to ask you? What do I do first to get y by itself? Okay. I mean, here's the idea. To get y by itself, I need the 5x and the 3y on opposite sides, right? We can do this either way. It's not going to matter as long as you get x and y on opposite sides. I am fine either way. What I would say is I'm trying to solve for y, yes? And I know how you guys are. You like to have what you're solving for on the left. So my suggestion would be we keep the 3y. And how do I move this positive 5x over to the other side? Since it's a positive 5x, and it's being held together with addition subtraction, we're going to subtract 5x. Which means I'm subtracting 5x on the other side. 5x minus 5x will cancel. Leave me with 3y. What is 0 minus 5x?
0 minus 5x.
Even simpler than 0 minus 5x.
0.
Negative 5x. Let's go with what's 0 minus 5.
Negative 5.
Negative 5, right?
So negative 5.
So we can really just say negative 5x. Now, if that was any other number, we'd have to leave the number there it was, wouldn't we? But since it's a 0, we can leave it as is. Is y by itself?
No.
No? How do you separate a 3y?
Divide by 3 of both sides.
Divide by 3. So now, y is negative 5/3 x. Now you can write that as negative 5x over 3, but to me it's just easier to say negative 5/3 x. Does that fit my form? It does, doesn't it? Okay. Since that fits my form, y equals kx, I'm going to say yes. And then what? Okay, if it's y equals kx, k is negative 5/3. I would skip D in the essence of time, but D's a good one. It is. It's a good one. Exactly. Fractions are always good ones for a teacher to talk about. Because you guys love fractions so much.
No, because nobody knows how to do it.
You guys choose to have this thing against fractions. Okay. Y equals, and then we see an x over a 9. And we want to know, does this fit the y equals kx form to make this direct variation?
Yes.
No.
No.
I don't think so.
I hear yes and I hear no.
No, because it's y equals x over 9.
Okay, right now you guys see y equals x over 9.
Yeah.
Could be more.
Okay. What is the invisible number in front of x?
1.
1. What if I write that?
Gosh darn it.
It's okay, Lana.
So, does this kind of remind you guys over here
Yeah.
where I have negative 5x over 3,
Yeah.
which could be written as negative 5/3 x? Anytime you have an x, there's an invisible coefficient of 1. So how could I rewrite this?
1 over 9.
Y equals 1/9 x, and guess what? This is why I said it's a good one. It's a tricky one, isn't it?
They always
Yes or
do.
no?
Okay. So, is this direct variation?
Yeah.
Yes. And what is my k value? 1/9. So just because it's x divided by a number does not put it out of the question. It can still be direct variation. Can you guys tell that's 1/9?
You can tell it's a number.
Yeah.
Yeah.
Sorry, there's just no opening in the middle of the 9. Okay. Example 3. Keeping us moving here. Suppose y varies directly with x, and y equals 9, and x equals negative 15. What is y when x equals 21? Okay, so there's words, right? We have to battle past the words. First of all, notice the phrase. Suppose y varies directly with x. What is our equation that represents y varies directly with x? Yeah, the ones at the top. When we talk y varies directly with x, that's y equals kx and k equals y over x. AKA the ones at the top, right? Now, with that in mind, they now give us a set of information. Y varies directly with x, and they gave us this set of information. So here's what I'm going to say. Forget that question. Don't think about the question yet. Y is 9 and x is negative 15. If they're giving me an x and a y value, what can that x and y value help me find? They can help me find k. Excellent. So we're going to take, and officially you can use either of these equations. If I'm trying to find k though, I like the idea of using k equals y over x. That's me personally. So if I do k equals y over x, then I'm saying k equals, what is it? 9 over negative 15. What do we know about 9 over negative 15 before we continue? It can reduce, can't it?
Yeah, by 3.
What can 9 and 15 both divide by?
3.
3.
3 over 5.
So if we divide these by 3,
5.
there's a negative, and a 3, and a 5. So what we know right now is k is negative 3/5. That's the reduced version. If you are a calculator devoted person, you're telling me negative 0.6 right now, aren't you? Okay? Which you could use, depending on what Math Excel wants you to do. But it's equivalent. I'm going to go fraction. Just because Math Excel tends to go fraction sometimes, right?
Math Excel
It is picky. Okay, so now, we know k is negative 3/5. The direct variation equation is y equals kx, right? So I can take this and write a new equation that says y equals, instead of k, I'm going to say negative 3/5 x. So now, if my question, what is y when x equals 21? What do?
Plug in negative.
Plug in
Regular 21.
regular 21. That's an equal sign.
Oh.
I get it though, I had to look too. Okay, so we're going to plug it in, right? So we're going to take y equals negative 3/5 times x, which is 21. What is 21 as a fraction? 21 over 1. And I do that because I'm going to have to multiply, aren't I? Okay. I like to check cross-canceling. 5 and 21 don't cross-cancel, so I'm going to multiply. Negative 3 times 21, negative 63. 5 times 1 is 5. I personally am fine with an answer of negative 63/5. It doesn't reduce. If it reduced, we'd want to reduce. Now, with that in mind, could you possibly have a decimal answer at this point?
Yes.
You could have, especially those of you that are attached to those calculators who can't get away from them. An equivalent calculator answer would be negative 12.6. As I said, in all honesty, there's a chance Math Excel will require the fraction answer. But a decimal answer is possibly okay as well. It just depends on how Math Excel reads, right?
Depends on how it's doing today.
Yeah, depends on its mood, right? Hello? I don't know. Are they waiting until after negotiations? I don't know. Yeah, I was going to say, Adam will be here this afternoon, so I'd ask him. Okay. Bye. Okay. Have you looked at the next one? Do I have fully time for the next one?
They have no light.
My plan is not on track today. My plan was we were supposed to be done with these notes. Yeah, we're not there. What happened?
We have to.
Alexis.
We did more homework questions.
Alexis.
Graciously helped.
Okay, gracious. So he's appreciating the fact that I helped you.
I appreciate
You
it.
helped us.
Which I think normally I help a little bit, but I think we were just chatty at the beginning of the period today too. So that doesn't, me and my whole confusion. So here's what I'm going to say. Obviously, we're going to have to pick back up in notes tomorrow, which was not my original plan. But you know what? Yeah, plans change. I've got enough people quarantined right now. They probably appreciate the slower pace because it's less they miss.
Yeah.
So, it is what it is kind of what I'm going to say here. So, here's what I would say. I would go ahead and start the homework. But I'm probably going to have to bump things.
Yeah.
I was trying to avoid bumping, but I'm probably going to have to bump things. So,
Guess on that.
yeah.
Yeah, we could just guess.
So, you can start looking at the homework. Tomorrow I will finish notes and you will have some work time, so plan to use it wisely. Okay?
No.
You don't like these,